All right, Helicopter Flying Handbook, Chapter 4, page 7 of 18 on an iPad or a smart device, Antitorque system. Just went over the swash plate. Now into the anti-torque system. Helicopters with a single main rotor system require a separate anti-torque system. This is most often accomplished through a variable pitch anti-torque rotor or tail rotor. Pilots vary the thrust of the anti-torque systems to maintain directional control, whether the main rotor torque changes or to make heading changes while hovering. Most helicopters drive the tail rotor shaft from the transmission to ensure tail rotor rotation and hence control in the event that the engine quits. Usually negative anti-torque thrust is needed in auto rotations to overcome transmission friction. So a fenestron. Another form of anti-torque system is the fenestron or the fan and tail design. This system uses a series of rotating blades shrouded within a vertical tail. Because the blades are located within a circular duct, they are less likely to come into contact with people or objects. NOTAR. Using natural characteristics of helicopter aerodynamics, the NOTAR anti-torque system provides safe, quiet, responsive foreign object damage, FOD, resistance, directional control. The enclosed variable pitch composite blade fan produces low pressure, high volume of ambient air and pressurize the composite tail boom. The air is expelled through two slots which run the length of the tail boom on the right side, causing a boundary layer controlled called the Conda effect. The result is that the tail the tail boom becomes a wing. Oh, neat. Wow. Flying in downwash of the rotor system produces up to 16% of the anti-torque required in a hover. The balance of the directional control is accomplished by a rotating direct jet thruster. In forward flight, the vertical stabilizers provide the majority of the anti-torque. However, directional control remains a function of the direct jet thruster. The NOTAR anti-torque system eliminates some of the mechanical disadvantages of the tail rotor, including long drive shafts, hanger bearings, intermediate gearboxes, and 90-degree gearboxes. I want to fly one of these things. So there's an air intake, and that comes kind of from the main rotor. Goes down the tail boom, and look, it shoots out the left side. Pretty cool. While in a hover, the Conda effect supplies approximately 2/3 of the lift necessary to maintain directional control. The rest is created by directing the thrust from the controllable rotating nozzle. All right. So this is going to go into anti-torque drive systems. So anti-torque drive system. The anti-torque drive system consists of the anti-torque drive shaft and the anti-torque transmission mounted at the end of the tail boom. The drive shaft may consist of one long shaft or a series of shorter shafts connected at both ends with flexible couplings. This allows the drive shaft to flex with the tail boom. The tail rotor transmission provides a right angle drive for the tail rotor and may also include gearing to adjust the output to optimal tail rotor RPM. Tail rotors may also have an intermediate gearbox to turn the power up a pylon or vertical fin. So we'll hold off there. That is page 8 of 18. Went into pretty much the tail rotor systems, the anti-torque systems. Yeah, the fenestron, the NOTAR. All right, we'll hold off there, page 8 of 18. See ya.